combine, if you want them to be able to react, what do you have to, how do they have to combine? In what way do they have to combine so that they can react?
They have to combine in a way that they can switch their...
Here's, that's right. That's right. And what way is that? Here's my pile of one ionic compound.
In the green.
Here's another pile of a second ionic
You
compound.
made that whole lot.
Okay, so I have two ionic compounds. Ionic compounds, what form do they come in?
Solid.
They're solid. They're salts. We learned that last
Yes.
class, huh?
Salt.
They call them salts. Now, does that mean that they're sodium chloride?
No.
No, salts
Unless it
just
is sodium
means that they
chloride.
are
Ionic.
ionic, and ionic means that they must be a
Compound.
Metal and
compound between a metal and a non-metal, or a metal and a what?
metal.
Or
Semi-metal.
like this.
A metal and a semi-metal.
No.
Multiple. Polyatomic.
What? A polyatomic ion. Polyatomic ion.
That's
What
not
does
an ion. It's not a polyatomic ion.
this one?
It's not a polyatomic
It is a polyatomic ion.
ion.
Right now, the charge isn't shown because it's combined with this.
Yeah, so I'm saying that whole thing is not a polyatomic
This whole thing is an ionic compound because this is an ion and this is an ion. This is a metal ion and this is a polyatomic ion.
That's
Correct?
magnesium sulfate.
Magnesium sulfate, yes. What's the charge on the magnesium ion in this compound?
Plus.
Plus what?
A positive.
A positive 2.
That's right, plus 2.
two.
How do you know it's a plus 2?
Because it wants
Because
the
it wants to
minus
lose
2.
That's right, it needs to lose 2 electrons.
Wait, but.
All right. So, if I want to combine these two salts, if I pour them together into another larger container and make a larger mountain of the two salts combined, they will not react. They won't react, Tom. Can you believe that?
Oh
Just because you
no.
put something together doesn't mean they mix.
Okay. So two solids, when you combine them together, have a hard time reacting because they're not interacting very much. They're not touching.
They're just lying on top of each other.
Mm-hmm.
With a liquid, they go in time.
That's right. So what do you have to do, Tim, to make these things interact better?
Add some water.
Add some water. That's right. If I extend this little container in and make it a flask or a beaker of some sort here, and then I add some water, as long as both of these are what?
Soluble.
Soluble. As long as both are
Then you
soluble,
won't get a mix. You'll get a solution, which might not be liquid.
then you'll get a solution of
Other than-
this and this together,
With the water.
and then, if they can react, they will react. Okay?
So if you really wanted to do it without the water, if you didn't want water in the compound, you would have to melt them together.
Mm-hmm. That's true.
Melt them together, then wait for them to, if you wanted them in
You can
solid,
grab a periodic table if you want,
wait for
Pearlie.
them to.
I'm right here, just grab this one.
All right, so then, that is a reminder. That is a reminder that to mix ionic compounds, really what you need to do is dissolve them in water first, and then mix them together. So when I write something like this, okay?
Quiet.
Yes, it's so quiet. Okay, I'm going to combine that with that.
And
Okay? When I combine these two together, I mean, it says here, but you might miss it if you don't know what you're looking at. What this is showing us is that this is a solution of this compound. What is this compound? Anybody know?
sodium phosphate.
Sodium phosphate. Sodium phosphate. And what is this compound over here?
Well, I have to be copper
Copper
chloride.
chloride. Just like sodium chloride, you say chloride, right? Okay, so it says AQ and AQ, so what does that mean?
They're both dissolved in water.
They're both dissolved in water. So, just because, I mean, I'm not always going to say, or
Wait,
when somebody writes this, they're not going to always be there to say, this is in water and this is in
So
water.
they
They
just
just
put
write
AQ.
AQ, right?
so the end, what you'll get sodium chloride.
Okay,
AQ,
so
and
now we can predict the products. We can predict the products. What will the products be?
Sodium chloride and copper phosphate. AQ. On the
Sodium,
chloride.
here's the two pairs, right? Here's one, and the other pair right there, 2 and 2, correct?
And then the phosphate and the chloride switch.
Yeah.
Places.
So then we're going to have sodium,
Sodium,
chloride, and what's the other one?
Copper phosphate. AQ.
See you.
Sodium. Oh yeah, we got salt and
PO4.
something. Salt and copper phosphate.
This is going to be 2, and this is going to be 3.
And then you're gonna have to put aqueous because they're still dissolved in water.
Okay, this one, well, I don't know. How do we know that they dissolve in water?
Well, we know that Na.
Na because it has.
First row.
Okay,
it's
so this one's
automatically
aqueous.
dissolved.
We know this one's.
Okay. PO4C.
Now we use our solubility rules, that's the little card I passed out,
PO4.
to see if we can predict whether or not this new compound, copper
Wait.
phosphate, is soluble in water.
It's not.
It's not soluble. It's
Rule number 6.
Rule number 6?
All salts that contain PO4.
Phosphate.
Alright, all salts that contain phosphate are not soluble, therefore this is a solid. Alright, so now
Wait,
you...
wasn't that what happened when we got the copper phosphate?
Yes, that's right, copper carbonate.
Copper carbonate turned into copper sulfate?
No, it's copper sulfate,
to copper carbonate.
with sodium carbonate, and it turned into copper carbonate.
And then there's a rule about copper carbonate.
Okay, so this is this is a new game called Predict the Products. Ding, 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 ding. All right, so here goes. I'm going to give you the compounds, and you predict the products. All right? Okay, here we go. 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 Predict the products.
What's NO? Nitrogen.
Nitrogen.
So, products are sodium, nitrate, and AG. Oh, silver chloride. So we mixed salt and silver.
How do you know
nitrate.
which one's to combine?
You just flip the
Well,
ends.
this is the positively charged ion,
And
correct?
you switch the negative
This
charge.
is the negatively charged ion.
You switch the.
Here we have the positive charge, and
So
this
is the
is
first one
the
You
the
just
negative.
switch the
The
negatives.
first one, the metal, is always the positive.
Well, you could either switch the metals or the negatives. It wouldn't really matter in this case.
It's
but
the same.
sometimes.
So,
Tommy.
the products are going to be what?
Sodium, nitrate.
Na. Let's let the people on the floor answer. Any ideas? What is the product? What's the new thing that's going to go with Na here? NO3. Very
Guys.
good.
That thing's 2 times soluble. 'cause
Excellent. Can you think the other product? Can you see what the other product is?
AG
Silver chloride. Very good. AgCl.
C is
Now we have to use our solubility table and find
Wait,
out
you
whether
forgot-
we think either of these are soluble.
Well,
Sodium.
Sodium that has is sodium and nitrate. That's automatically AQ.
Okay.
Well, if you put it in water.
All right.
But the other one is trickier because it has column 7.
It has column 7, so it must be
It has
soluble,
group 7,
right?
except it has silver. Which
Yeah,
is
silver is the
Oh, so what rule does that say? What rule is that?
Rule 3: all chlorides, bromides, and iodides, salts containing
Chloride ion,
or
bromide ion, or
are
iodide ion.
soluble except when combined with silver, lead, and
Mercury. Okay, so what does that tell us? That this one is what?
Not soluble.
Insoluble.
Insoluble. So what do I write down here to show that it's insoluble?
Solid.
S for solid. Very good. This one here is,
Aqueous if it's dissolved in water.
it's always dissolved in water. Okay?
Alright, well you forgot to put aqueous up there.
Well, I didn't want to because I want you guys to start recognizing that if they're ionic compounds, they have to be dissolved in water. Okay, here's another one. Ready for this one? You all ready for this?
Yeah, I think.
Now walk me
possibly.
well. Walk me now.
No, two. You went to this. Win. Oh no. Win.
You all ready for this? Oh no, don't remember
What's that
It
from?
didn't break.
Lego movie.
Because it's credible.
Okay, here we go.
Chewing gum.
Predict the products. Ding, 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 ding. Tell your neighbors. Tell your neighbors. Couch, mini couch, mini couch. Talk to your neighbors and tell them the products, mini couch.
Wait,
What do you do with this?
Predict
What's CLO
your the
What's
product.
CLO for? What's CLO for? Is it
Use your neighbor first. See if your neighbor knows.
chloride something?
Okay, Tom.
It's chloride oxide.
See if you can find it in the
Perchlorate.
solubility table.
Solubility table.
CLO4. If it contains it, it's soluble.
K is potassium.
Yeah, I found K is potassium. Fe is iron. And
So that is a C. What is C? Where is K?
I think
It's
oh, it's in the alkali metals.
Alkali metals.
Alkali metals. Oh, well, I figured out what the products are. I don't
You
know.
did? You found out what the products are?
So it's
How about couch?
potassium.
Big couch. Anybody on the big couch tell me the products?
That is the first one is potassium iodine.
K I.
Soluble.
And what's the other one?
And the second one is
Iron.
iron.
I don't know what that's called though.
Perchlorate.
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 And both of them are soluble? I think, yeah,
L
both of them are soluble.
O 4.
And both of them are
And there
soluble.
needs to be a couple of these.
Okay, first one is soluble.
Both
So
ones are
it's
soluble.
This is aqueous. How did you know?
it has the alkali.
Potassium. All
You
right.
forgot to put the two away.
There's not a 2 there for that one.
Oh, really?
And this one?
That one's soluble because it has group 7 and doesn't have silver.
Is that group 7?
But
This isn't a group 7. This isn't chloride. This is a perchlorate.
Wait, it's because it's soluble.
It's soluble
It's
because-
soluble because of rule 2. Also containing NH4.
Rule 2?
And then
What's rule 2 say?
All
NO3
salts containing NH4 plus
minus
ClO4.
So what?
It's soluble.
It's soluble.
Aqueous.
So, what were the products of this reaction?
Potassium iodide and iron.
Okay. Now, think about what we did. Think about what we did, what this reaction says. Tom, time to use our ears a little bit more because this is an important concept that you need to recognize. We said in the beginning that if I want to mix ionic compounds, I have to have them in what? Water. I have to have them floating around in water. Now, we talked about this before, but you might have forgotten. What happens when I put an ionic compound that's soluble into water? It dissolves, and it also what? Separates into its ions. So now this is a positively charged potassium ion, and then there's the ClO4 minus ion.
That's why they
Correct.
switch.
And in my second bottle, what did I have?
Iron iodide.
I have iron ions, Fe. What's the charge on the iron ions? Can you tell?
Plus. Positive charge.
How can you tell what the charge is on the iron ion? Positive, positive 1, positive 2, positive 3.
Positive.
Because it's a metal.
It's positive, but what
Positive two.
positive is it?
Positive
1,
two.
positive 2. How do you know?
Because it says on.
Lots of metal. Lots of.
Yeah, metals usually want to lose too.
It's because iodine has what kind of a charge?
Oh, because iodine has a negative
Negative
one
one.
charge, and if there's two of
And
them,
there's
then
two
that
of
means
them.
they're
That
sharing
means this
two.
has to have a +2 charge. All right, so this is a +2, and then the iodine has a -1 charge.
And then
So I have two solutions, correct? I mix them together into a bigger solution, and now what do I have in here?
Now you have.
We decided this is aqueous, so I still have potassium ions over here. I still have iodide ions over here. And what do we talk about this?
Still like
It's still aqueous too, so I just have iron ions and iodide ions, or iron ions and perchlorate ions.
So they're all separate in that.
They're all still separate. Nobody changed partners, nobody interacted with each other at all.
So you have to drain out the water, but leave.
No,
Yeah.
what you'd find out is that this is not a chemical reaction, because there's no change that occurs.
So you have.
If
So to really
the products are both aqueous, when you combine ionic compounds, then we say
It's just a bigger solution.
no reaction.
It's just a bigger solution.
And
Time to stop.
It's 8:16.
8:16. Ah!
It's just a bigger reaction.
All right.
It's just a big. You just
The
making a bigger
end.
solution.
See you tomorrow.